We all know uranium, known for its radioactivity, a phenomenon that powers our cities and also holds the terrifying power to destroy them in seconds. But the astonishing fact is that this effect was discovered by an accident. In 1896, when the whole world was fascinated by newly discovered X-rays, a French physicist named Henri Becquerel stumbled upon something even more mysterious. A question formed in his mind. Could fluorescent materials, those that glow in sunlight, also emit the mysterious X-rays Röntgen had just discovered? He placed uranium salts on photographic plates, wrapped them tightly to block out light, and set them in the sun, expecting the energy from light to trigger the rays. But the skies over Paris turned gray, and the experiment had to be postponed. He tucked the plates away in a dark drawer, unsure of what he might find, waiting for the skies to clear. The next day, he developed plates anyway, and was stunned. Even without sunlight, the plates were fogged, as if light had passed through solid paper. He realized something extraordinary. Uranium was emitting its own invisible rays, spontaneously, naturally, from deep within the atom itself. That moment in Becquerel's dark drawer lit up a new era of science, revealing that matter itself was alive with hidden energy. This discovery also shattered a centuries-old belief that the atom was the smallest, unbreakable unit of matter. But you'd be wrong to think Becquerel's discovery was pure chance. From the moment he was born, the stage was quietly being set for this extraordinary accident. Let's explore why this accident could only have happened to him, the one that would ultimately earn him the Nobel Prize in physics. You might think it was luck, the right place, the right time. But here's what makes this story remarkable. This accident could only have happened to Henri Becquerel. He was born into scientific royalty in Paris in 1852, inheriting one of the most distinguished scientific legacies in history. His grandfather, father, and eventually his son were all physicists, each succeeding the other in the same chair at the prestigious Muséum National d'Histoire Naturelle. Science wasn't just his career, it was his birthright, and he was immersed in it from his early childhood. After studying engineering at the École Polytechnique, he settled into the family profession, dedicating his life to studying light, magnetism, and phosphorescence, the exact subjects that prepared him for his accidental breakthrough. The accident only happened because he was prepared to observe the unexpected. Early in his career, Henri Becquerel was fascinated by light. He conducted extensive research on luminescence, the phenomenon when materials absorb light and release it later. He studied phosphorescence, the phenomenon in which a substance continues to glow even after the stimulating light source is removed. He carefully examined how different crystals absorbed and released energy, uncovering patterns in their mysterious glow. He even experimented with infrared radiation, using phosphorescent crystals to reveal parts of the spectrum invisible to the human eye. Every experiment was a step toward a discovery that would change science forever. His research was rooted in optics and electromagnetic phenomena, focused on the rotation of plane polarized light by magnetic fields, an extension of the Faraday effect, and detailed studies of luminescence and phosphorescence in materials, particularly uranium salts, which formed the basis of his 1888 doctoral thesis. When Röntgen announced X-rays in 1895, Becquerel didn't just get curious. He was the only person in the world positioned to make this leap. His entire career had been built to this moment. Becquerel knew he'd found something extraordinary, but he also knew his limits. He handed his uranium samples to his colleagues and brilliant young doctoral student named Marie Curie and her husband Pierre. That decision changed history. Curie's isolated radium and polonium. Marie coined the term we still use today, radioactivity. In 1903, all three shared the Nobel Prize in physics, Becquerel for discovering the phenomenon, and the Curies for unraveling its meaning. Together, they opened the door to a new era of science. Henri Becquerel's discovery of radioactivity didn't just earn him a Nobel Prize, it transformed science forever. In medicine, It opened doors to diagnostic imaging and early cancer therapies, giving doctors tools to see and treat the invisible. In science, it helped unravel the mysteries of time itself, allowing researchers to date the Earth and laying the groundwork for nuclear physics and quantum theory. In energy, his work planted the seeds for nuclear power and, inevitably, the development of nuclear weapons, shaping the modern world in profound ways. Becquerel dedicated his life to pure research, a quiet life that revolved around his laboratory and his classrooms. He passed his passion to his son Jean, keeping the family tradition alive for one more generation. Today, his name lives on in every physics textbook. The unit of radioactivity, the Becquerel, honors the man who first revealed the hidden energy humming inside every atom. He taught us that the universe's greatest secrets aren't violently torn from nature. They're discovered by prepared minds paying attention. Every medical scan, every nuclear power plant, every smartphone in our pocket, all of them can trace back to one cloudy afternoon in Paris, the day a miracle unfolded. For more stories of the world's greatest minds who uncovered the unseen, hit that like button if you still believe curiosity can change everything. Share this with someone who knows discovery isn't just found in light, but in the shadows. And drop a comment if Henri Becquerel's story made you see science in a whole new light. Because this is Awards, where the world's greatest minds live forever. Don't just watch history, be inspired by it.
Thanks for being with Awards. Subscribe to know more about international award winners and unsung heroes behind peace, science, and humanity.